So electrical test bench. This test bench can be used for any circuits for development and for R&D purposes. This test bench consists of voltmeter, two AC voltmeters, one AC ammeter, one DC voltmeter, another DC voltmeter, and four DC voltmeters and 120 amps DC meter. And then we have this one number 18 amps 3-pole contactor of 18 amps 1, 2, 3 and 4, and all terminals have been brought out. This is T1, T2, T3 and NO 1 point, L1, L2, L3 and NO point. And this is auxiliary coil voltage 230 and this is NC NO of a contactor. Say if you want to use this contactor externally, you need to use these terminations for operation. Like this, we have given 4 contactors of the same current rating 18 amps. Simultaneously, we have given another SSR relay of 25 amps and this will operate from 4 to 32 volts. This is 4 to 32 volts input and this is your contact. And then here we have used one RCCB of 40 ampere current rating of 3 phase. This can be used for 3 phase. This is my input and this is output. You can give input 3 phase and you can take out a 3 phase output from here by using this. For any leakage current, this will get tripped and then you need to press this. And then here we have 3-pole MCB of 32 ampere. This is again input and the output is 2-pole RCCB of current rating 40 ampere and the leakage current can sustain up to 100 milliamps. And this is another 2-pole plain AC MCB is the input and the output. And then here you have 4-pole isolator. So if you want to use this 4-pole isolator, this is your input 3 phase and the neutral, and this is 3 phase and the neutral output. And then this when you switch on apply 3 phase supply, there is a MCB mains MCB here, Once you switch on this, your R indicator, Y indicator, blue indicator should glow. So once you switch on, all my meters will glow. Simultaneously, you will get 3 phase supply here. You will get fixed 3 phase supply R, Y, B and N. Whatever the input voltage will be the same. You will get the same voltage. Simultaneously, for single phase experiments, we have given 1 phase and neutral. And this has been protected by a fuse. So if you want to use for any single phase supply for your research purpose or development, you can take use of this supply. And then we have another contactor here. The difference between the top and the bottom contactor is here you have OLR. OLR means overload relay. Say this current can be adjusted from 0 to 15 amps. And then if it trips, this you need to reset. Again simultaneously you have auxiliary of 230 volts. This is your input and this is your output. You can adjust your current settings. Here you have a variable AC source here. If you vary this knob, the output voltage will vary from 0 to 230 volts. And this has been protected by a fuse. This fuse current rating is of 2 ampere current. And the second source is this. By using this knob, you can vary the output voltage from 0 to 120 volts. Again, that 120 volts you will get across this terminal. And this is also protected by a fuse of 2 ampere current. And this is variable current injecting source. By varying this, you will get 0 to 20 ampere current across these terminals and the fuse rating is 20 ampere here. And then we'll go back to this protection relay. This is under over voltage relay. So this is under over voltage relay. This is also under over voltage relay. Say to sense this relay, you need to apply 3 phase and a neutral, and these are all the contacts. Say to operate this or to set the voltage, fault voltage, you need to do programming. This programming video will be shown to you later. This is also 3-phase under over voltage relay, and this is single phase over current relay. So for sensing current, you need to apply across this is CT primary. These are all contacts, common, NO and NC of the relay. You need to program according to your requirement. This is 3-phase over current relay. This is RCT primary, YCT primary, BCT primary. Secondary of the CTs are being connected internally to the over current relay. This is timer. This timer can be used as a stopwatch as well as a timer. Say if you want to use this as a stopwatch, so you need to press this. It will start ticking. Once I remove the finger, it will stop. If you want to do it again, you need to switch off this or reset. And then these are all normal relays of different voltage and current ratings. This is 230 volt 6 ampere. This is 230 volt 12 ampere. Say again here we have mentioned the voltage here. This is coil terminals. This is there, it is 2 changeover relay. For that reason, this is first common NO NC, and then this is second changeover common NO and NC. This 230 volt, and the current rating you can see here. And then this is also 230 volt, but the current rating would be around 10 ampere. Like similarly, this is 12 volt 6 ampere, 12 volt 10 ampere, 24 volt 6 ampere, 24 volt 10 ampere. So you can use all these relays by giving auxiliary to the auxiliary terminals, and you can make use of contacts. And then we'll come back to the last portion of this test bench. These are all neon indicators. If you want to use any neon indicators for your circuit, you can use these 2 terminals. All these terminals indicators are of 220 volt AC. Say if you apply 220 volts across these terminals, this neon lamp will glow. Similarly, this also 220 volt AC is also 220 volt AC. This is DC neon lamp. This will glow at 220 volt DC. And this is push to on switch, push to off switch for any breaker, and then you want to switch over any motor and you want to use it as a DOL starter. You can use this push to on and push to off. This is NO contact, this is NC contact. And then this is VFD. This VFD works on single phase. You need to apply single phase, but the output could be 3 phase. By using this potentiometer, you can vary the output voltage from 0 to 415 volts. This also will be shown to you later. And then this is an inverter, grid inverter. Grid inverter has been fitted in the side panel of my test bench. This is my grid inverter. This is input will be DC and the output will be AC, inverter output. Thank you.
Now we can go through the relay programming parameters. This is single phase over current relay, and this is 3-phase over current relay. Coming to relay keys, functional keys, this is set key, this is increment key or increase purpose, and this is decrement key for decreasing purpose, parameter setting purpose. And for programming the relay, you need to press this set key for 5 seconds. And they have provided menu like this, and here there are 3 different menus. First one is relay trip parameter menu, and second one is protection menu, and third one is trip CT ratio and trip setting menu. And for the each and menu, they have provided a password protection, password 11 for relay trip parameter settings, password 73 for relay percentage trip percentage setting, and password 37 is for CT ratio and trip time delay for all settings. Now you will see relay trip parameter settings. Now we are entering password number 11. See, you can go through this OC. OC means overcurrent settings. Overcurrent settings enabled. ENB means enabled. Next, similarly, these are the some other protection parameters which we don't need. And this is our again back to main menu. You can find out L1 current, L2 current, L3 current. By pressing down key, you can change the current settings. Now we are setting trip value percentages. For setting trip value percentages, password 73 we need to enter. So this is password 73 we have entered. Now you can find out overcurrent setting. This is 80% of the CT primary current. My CT primary current is 10 ampere. So it is 80% we have programmed overcurrent. Now this is connection part. Coming to connection part, we are going to trip the overcurrent relay by having some current source. So this is my current source provided here, and these are my push buttons. This is on button, this is off button. Now you can look at the ammeter. I am applying the current of 9 ampere. This is my L1 current, and my relay got tripped because overcurrent fault. OC overcurrent means. Similarly, this relay also works on the same function, overcurrent function. Same overcurrent function. These are the relay inputs. These terminals are relay contacts, outputs. Difference. This is a single phase overcurrent relay, and this is 3-phase overcurrent relay. Whenever relay got tripped, you need to press this key, down key, for resetting the relay. Whenever you press this key, down key, relay will be automatically reset. Now we can have basic contactor wiring. Now we are taking single phase supply from here. This is phase, this is neutral. My phase, single phase wire is connected to push button NC terminal, one end, and push button NC terminal another end is connected to NO, one end, and NO another end is connected to contactor coil phase terminal, and contactor coil neutral is connected to neutral terminal, supply neutral terminal. And take one more patch cord, connect here, NO terminal phase connection, and this NO connection is connected to contactor NO terminal. Again contactor here, from contactor again NO terminal to contactor coil. This is latching connection, contactor latching connection. Now you just press this green button, you just look at the contactor. This is the contactor operation. Now coming to these two are voltage protection relays. these are the terminals, relay voltage input terminals. These terminals are contacts, relay contacts, NO, common, NC. Two channels. This is channel 1, this is channel 2. Coming to programming menu, same procedure. Press the set key for 5 seconds. It will ask password. Password will be 11. So password 11 we have entered. Now you can look at the protection functions. Over voltage enable, under voltage enable. Remaining functions not required. And coming to back main menu, this is our main menu. Now you can look at the voltages. L1 voltage, L2 voltage, L3 voltage, and this is frequency. And coming to fault settings, percentages, the password will be 73. Now you can look at the over voltage value is 220 volts. The fault whenever above 220 it will be like over voltage fault. Similarly, next under voltage fault, this is also 220, less than 220, whatever the voltage will be treated as under voltage fault. This is the programming.